In this section, we'll write a simple HTTP server that'll give us a hello world and a goodbye endpoint. We'll also write tests that cover both. Let's get started. As you can see here, I have a new project, and I've called it HTTP server. Here in the main package, let's go ahead and validate that our environment is set up correctly. In order to do this, I'm just going to write a quick hello world. And you can see that my IDE has helpfully managed my imports for me. Most IDEs will do this now, but if yours doesn't, then you'll need to manage your imports yourself. Let's go ahead and run this. And as you can see, we got our output here as expected. Now that we know that our environment is correctly configured and that we can successfully run code, let's go ahead and dive in. We'll delete this, and we'll add a basic HTTP server. For this, we're going to use the HTTP listen and serve method. The first argument is an address. For this, we're going to do 8080. If we do this, it'll cause it to bind to all IPs on the host machine on port 8080. If for some reason this port is already in use on your machine, then go ahead and just pick another higher level port. You'll just have to remember to change it in the address bar later when we do testing. The other thing that we need is a pointer to a handler. For now, we're going to use nil. If we mouse over this, we can see our inline documentation here, and it has an example for us. In this case, they've done the same thing we have. You can see here that they call out specifically that the handler is typically nil, in which case default serve mux is used. That's going to be fine for this step. You can also see here that they call out that listen and serve always returns a non-nil error. And in the example, they've wrapped it in log.fatal, so that if this server is to crash, then we'd at least have a console output to help us understand what had happened. We're going to do the same thing. Log.fatal basically writes to the console and then immediately exits the program. Now let's go ahead and run this. And you can see that it has started, but nothing has been output to the console, which is to be expected. We didn't tell it to output anything, but it is still running, as you can see here. Now let's add a handler. For this, we'll just handle the root path. And let's call it handle hello. Obviously, this does not exist yet, but we can make it. An HTTP handle func needs to take two arguments. The first argument is an HTTP response writer. The second argument is a pointer to an HTTP request. But because we're not going to use the request, for now let's just make it an underscore. You'll also notice that this does not return anything. That's because data will be written to the response writer as part of this when the server handles it. Now, let's go ahead and write some data to our response writer so that we get something back. We're going to call write on the response writer. As you can see here, write takes a slice of bytes and returns an int and an error. The int indicates how many bytes are written. For this, we're going to use a hard-coded byte slice, which we can create like this. This is unlikely to fail, but if there was a failure for some reason, we would have a problem. When this call happens, it will set the status to OK. But if there was to be an error, we do still want to know about it. Let's go ahead and just log it. And slog will require a key value pair for the response, so let's just go ahead and call it error. Importantly, we need to return here, so that nothing else gets processed. In this case, there won't be a whole lot, but it's just good to remember. But we still have the number of bytes written. For now, let's just print them out. With all of that set up, we should be ready to test. Let's go ahead and run our program. As you can see, nothing is output yet, which is to be expected. We still haven't told it to print anything out until this is handled. If we open a web browser and point ourselves to localhost 8080, we can see that hello world is returned, as expected. You can see here that it actually responded twice with bytes written. This is likely because the browser also requested additional information such as a favicon, but we only handle the root path. But this will match all paths. We'll talk more about that later. For now, as long as you see a response written, that should be sufficient. Let's go ahead and pull up our API testing tool. We need to add a new request. And you can see this is already set to GET, which is going to be fine. If we fire the request off to localhost 8080, we also see hello world. And we see another log message is printed. Everything appears to be working. We can move on. Previously, I mentioned that this is going to use the default serve mux. This is going to be a global variable, and it's possible that a different file within the same package could actually use that and change that in ways that are unpredictable. This could be malicious or just accidental and cause a bug. Let's go ahead and add our own mux so that we don't have that happen. We can do this very easily by calling http new serve mux, and we'll call it mux. Now, instead of http handle func, we'll use mux, and we'll also go ahead and give that to our listen and serve function. As a side note, right now we're using listen and serve because this isn't a production system. Listen and serve TLS has almost the same signature. It just requires a cert file and a key file. Please use TLS in production, whether that's at this level or at a load balancer or a gateway or something else. That's beyond the scope of this course, but just keep that in mind for security. We'll put that back for now. Now let's go ahead and add a test. I know this is a pretty simple endpoint right now, but it's good practice. We'll add a new file. And I like to name the test file after the name of the file in which the functions that it's testing live. We name it _test.go. Go knows that things that are named _test should be run by Go test. I like to put my test code in a pane next to the code that it's consuming so that I can refer back and forth easily. Let's also close this for now. Because of the way the Go test package works, we need to start the name of our test functions with test. You can include underscores in the name if you like. I prefer just to keep it all simple in one word. I'll also append the behavior I'm testing if that's relevant. For this, let's just go ahead and name it test handle hello. In order for this to be a test, we need to include a pointer to a testing.t. For this, we're not going to be testing the server machinery, we're going to be testing the handle functions directly. I prefer this because it allows me more control over what gets passed into the handle func. In a production system, I would establish end-to-end testing that treats the entire service under test more like a black box. I would probably do this in Go, but you don't have to. For this, though, we need to go ahead and provide our handle func with a response writer and a request. Fortunately, the HTTP test package can help us here. We'll call new recorder, which will provide us with a response recorder. Because the response recorder here will implement the response writer interface, we can actually provide this directly to a handle func as the response writer. We're going to call this W, because conventionally we call this response writer W, and it'll just help us keep things straight in our heads. Now, we call the function. And because we're not actually doing anything with this request, we can just pass in nil here. When we call the handle func, it's going to write the response data to our response recorder in the same way it would write to the response writer in a real request. That means that we have everything we need now to determine if this status was correct. First, let's go ahead and define a variable for the status that we expect, and you'll see why in a minute. And we want this to be a status OK. Now we can check it. If we look at the documentation for response recorder, we can see that this has some helpful properties. First, it has the code, which is the HTTP response code. It also has our headers and a body, which is a bytes.buffer. For now, let's just check the code. And let's output a meaningful error message here using a format string. Let's also output the body. The reason for this is that oftentimes error messages in the body can help you to determine what went wrong. Now for these parameters, the desired code, the code we actually got, and the body as a string. Because body is a bytes.buffer, we can just call string or bytes on it. Let's test. And we can see that we have our bytes written print message, and that the test is passed. But let's make sure we're testing this correctly. Defining this as a variable makes this very easy. Let's just say we wanted to see an internal server error. We run this test again, and we can see that we got a bad response code, because we expected 500 but got 200, which is correct. Let's put this back. And if we run once more, we're back to passing. Let's also validate the body. For this, let's define our expected message. It should be exactly what we told the server to write in this case. Now, we can do this comparison. And remember to call bytes on the body, because it is a bytes buffer. In case of a failure, let's output a meaningful message. And we'll do these as quoted strings. In our output, let's go ahead and call string on this as well. Now let's run this. And you can see it's still passing. Let's validate that we're checking this correctly though. What if we forgot to type an exclamation point? And you can see it would fail. We are correct. Let's go ahead and put that back in. And then we can rerun our test. Everything is green. Now let's do a challenge. We're going to add another endpoint to this server that's going to return goodbye in the same way that we've returned hello world. It's going to go on the /goodbye endpoint. For this one, let's go ahead and write the test first. Pause the video and give that a try now. Hopefully that wasn't too hard. Let's go ahead and walk through writing the test. We're going to call this one handle goodbye, so let's set up a test function. Same way as before, we're also going to need a new HTTP test recorder. And then we'll have to call our function, which won't exist yet, but that's okay. We'll set up a variable for the desired code the same way we did before. And we'll check it the same way we did before. And we'll also check the body. Obviously, we won't be able to run this just yet, because this function doesn't exist, but we can create it very easily. Also, don't forget that we need to tell the mux that it can handle this. And we'll put it on /goodbye. Now for the next step of the challenge, go ahead and implement this handler. Hopefully that wasn't too bad. Let's go ahead and implement this. And now let's run our tests. I like to run all of them, so that we make sure that we didn't break anything in the previous tests. It's unlikely in this case, but it's a good habit to get into. And all of our tests are passing. Now let's run the server again. And if we go back to our testing tool, we can see the hello world is still working and bytes have been written. And we can test our new path. And we see goodbye and bytes written. We also see that there is less, which makes sense because this string is shorter. Let's go ahead and stop the server. And because everything appears to be working, we can move on to the next step. And that'll wrap up this section. Thank you very much for watching, and I hope you learned something. If you'd like to support me and help me to create more content like this, check the video description below for ways in which you can do that. You can also just share this video with your friends, and that'll help a lot too. Thank you very much again, and we'll see you in the next one.